So at a glance, Aclara has 2 ionic clay deposits in Brazil and Chile and say that they've got the ability to produce significant volumes of heavy rare earths. CFO François Motte is here to essentially walk us through the company's shift from junior miner to what they say is a tech-forward mining business. So, François, first of all, welcome to Toronto.
Thank you very much.
You're called a tech company with mines, specifically ionic clay deposits. Can you walk us through the significance of that distinction?
Of course. So, first of all, you need to think that ionic clays are a very scarce deposit in the world. They occur in China, in the southern borders of China, and in some countries in Southeast Asia. So, having found them in Brazil and in Chile is not common. And what is the particularity? The ionic clays are the main source of heavy rare earths for the world, specifically dysprosium and terbium, where the focus is today. So that's exactly what we have in Brazil. We have a copy-paste, as we call it, to those deposits. And that's where we anchor our strategy. Now, we go a little bit further, and we have developed the technology to produce them, environmentally friendly way. And also we have integrated vertically, to refine them, we call it value aggregate, into more refined products that will go into the magnet. So that, because initially we're going to produce a concentrate, but the concentrate is not enough, to get into the permanent magnet. So there are some midstream stages that we are also solving, but that we're doing in the United States.
Yeah. So the idea is to work to a point where you're going to be controlling the end to end, right? From out of the ground to getting it to the market for available buying.
That has been the most important thing, because we see several midstream projects, but if you don't have the feed, then your project has a huge risk. And again, talking about scarcity, then the risk comes even higher. So having the feed makes our midstream project, our vertical integration, very reliable from a feed perspective. And also, as we have already completely de-risked the initial part, which is the mine, it also reduces the risk for the further stages. We are now developing the separation and also the metals and alloys. But we have also made an alliance with a magnet maker. It's called Vakuum Schmelze. They're from Germany, but they are putting a footprint here with a plant in the US. So that's a way for us to integrate from mine to the magnet and ultimately to the end customer.
And, you focus specifically on heavy rare earths like terbium, for example. Why is that?
Yes, the two main elements are dysprosium and terbium. And first, we need to think why they are important, right? So permanent magnets are important in some applications to be able to reduce the energy consumption of those applications. Meaning that, for example, if you have an electric vehicle, you can reduce the battery size because you have permanent magnets in the motor that help, rotating the motor without requiring that much energy coming. Now, you can have those magnets only with light rare earths, and you say, okay, why then you need heavy rare earths? It is because of temperature issue. The permanent magnets get demagnetized when they get over 60 degrees Celsius. So if you add dysprosium and terbium, and it's not much, the technology for permanent magnets have made that this amount is very small. It's around 1 to 3% only in the magnet. You can increase that temperature resistance to between 150 degrees up to 240 degrees. And that makes it a great solution for the end applications. And I'm going to put as an example, electric vehicles. Those motors tend to heat a lot. So you don't want to spoil your motor very quickly. So that's a way of enabling that technology for EVs. Mm-hmm. Similar, it happens to wind turbines. Wind turbines rotate with the wind and generate energy. But if they have these permanent magnets, those help the rotating, creating more energy, but they also tend to heat. And then you need to add this little dysprosium and terbium. It's grams, actually, that help you overcome that problem of permanent magnets.
And when we look at the data right now, the supply-demand concern is emerging. For example, one data is that heavy rare earth demand is expected to hit about 5,000 tons by 2030, while currently it's at about 2,500 tons. Yes. Why is it that the market seemingly has responded kind of slow? It hasn't really caught up yet.
Well, the main reason has been the strategy of China. China has been feeding the market with its magnets at very low prices. So customers feel very comfortable. China has a great technology. They control mine to magnet. They received a perfect magnet that works in their vehicles, and they're well used. So why taking all the effort to do everything outside of China, get this tremendous investment, deal with mines, with separators, with metal makers, with magnet makers, when you have all that solution at a very cheap? So that has been actually what has prevented the West to advance much faster. But now, with the restrictions that China has imposed, and this is the second time, because this already happened in 2010, the automakers do not want to feel trapped in the hands of this geopolitical issue. And I think there are more decisiveness now to say, okay, let's secure these elements. Specifically, the heavy rares that are the ones restricted.
Right. Well, so far, do you think that Western governments have been efficiently looking for these alternative ways to source heavy rare earths?
I would say I'm still concerned because the programs now that the governments are trying to do, they're trying to accelerate what exists now. And what exists now, if you look at the demand supply dynamics in the future, might not be enough. So yes, there are good programs in several Western governments, Europe, Canada, US, Japan. They are putting a lot of effort to say, okay, this is what exists. Let's try to bring this as fast as possible to production. And they are doing that with, the subsidized debt. They are doing that with investment. They are putting floor price, as we've seen with the MP materials deal and the DOD in the United States. So all of that is a huge help. But we are already behind the race. We need to find more resources in the future. But it's a great help. It's a good beginning. And I think this is our very interesting moments.
Well, to close it off, again, your deposits are in Brazil and Chile, and production is expected to start up in 2028. What else needs to be happening at a gradual level when it comes to, key milestones you've got to hit so you can get from clay in the ground to sellable products in the market?
So in Brazil, first thing is we are about to issue our PFS next month. So that's an important milestone. I would say that is more or less the numbers you're going to see for the project. Then it's just doing more engineering for the feasibility study. The feasibility study is targeted by the first quarter of 2026, by the end of it. And in parallel, we have to run with the permit. Permits are super important, especially talking about mines. So permit related to the environmental assessment is going to be approved towards the end of the year, latest the beginning of next year. And that will allow us to start some early works next year. The early works for us are very important because it will help to accelerate the construction of the Carina project. And that is roads improvements, camp, ancillary infrastructure, and some long lead item orders. That's Brazil. That will produce a mixed rare earth carbonate. I'm going to jump to the US just to follow the flow, and that needs to have a house. And today, the house is the separation project that we're building in the US. So we have not announced the location yet, but we are very sure where it's going to be. But what we have announced is that we are going to be piloting our process in Virginia Tech University in a partnership with them. We are installing the plant at this point. It's starting to operate the first line next month, and the full pilot plant will be ready operating by the end of Q1 2026. This is very important because it will validate all the lab work that we've done in the last 2 years. It will produce the samples that the customers want to validate, and it will give us the possibility to give the investment decision towards mid of 2026. This is important because we're timing these two assets. The separation is tailor-made for the Carina project. Engineering is already starting for that project also with Hatch in September. So I think that in terms of timing, it's important to consider that we view this as a one project. That's why I want to. Chile is also advancing well. It has cost us a little bit to get the permit. The permit we are aiming to receive by the end of the year. The government has shifted a lot in posture, specifically regarding critical minerals. They want to support it now. At the beginning, it was a little bit tougher. We see getting this permit at the end of the year. We are a little bit behind with engineering compared to Brazil. The FS will be towards mid-year or Q3. And then we will take the investment decision. And our ideal scenario is also send that concentrate to the separation facility in the United States.
Understood.
And the final thing is separation, metallization. Let's not forget that. We don't talk too much about it, but it's important for us. After producing the separated rare earth oxides, we're going to metallize them and doing the alloys. And we are also advancing very well. We're going to have our PFS by the end of the year. And we are looking to put a demo plant next year, contingent to get funding. So, but still in our plans.
Okay, Francois, we're going to leave it there for now, but thank you for making the time.
Thank you so much, Rachel.